Welcome to ECE 476 Advanced Embedded Systems. This is the first of about 35 different lectures where we're going to go over a Raspberry Pi Pico and a programming language called Python. Now, in terms of the intended audience, this course is really targeted for electrical computer engineering majors at North Dakota State University. This is an elective course for electrical engineers, an elective course for computer engineers, and a required course for software engineers. Now, that being said, I kind of suspect this course is going to be pretty useful for the general public as well. We'll be covering Python programming on a Raspberry Pi Pico and using a GeeekPi Pico Breadboard Kit Plus. That's actually a really nice kit that I'm kind of excited about using. It's Raspberry Pi Pico with a graphics display. Just a really impressive board. What we're going to go over is programming a microcontroller, specifically a Raspberry Pi Pico-W. The use of a development board. The one I'm targeting in this class is a $32 board you can get on Amazon, a GeeekPi Development Board Plus, and mid-level programming with MicroPython. Now, a resource, if you go to Bison Academy, let's see, where's that at? So Bison Academy is the semi-official website for the Electrical Computer Engineering Department at NDSU. If you scroll down, these are the various courses that we offer online. They're free and available for anyone to use, NDSU students, anyone else, we don't care. Scroll down to 476 Advanced Embedded, there's the course. So if you're not an NDSU student, you have access to everything as well. A little bit of background on this course. Now, we're going to be using a Raspberry Pi Pico. That's a microcontroller that just came out. Part of the origin where that came from, back around 1980, the IBM PC came out. Now, when the PC came out, it had an operating system called the DOS, Disk Operating System. That was a very good operating system for electrical computer engineering majors because it gave you complete access to the hardware, and that's what we like. We want to be able to control the inputs, outputs, so the PC was just a great computer for engineers to use. Well, around 93, Microsoft came out with Windows operating system. Now, the Windows operating system is much easier to use than the disk operating system, but it protects you from the hardware, which 99% of the people like, but those of us in electrical computer engineering don't like that because we want access to the hardware. So, in the year 2012, the Raspberry Pi came out. Now, the Raspberry Pi is a full-blown IBM PC built around an ARM Cortex processor with 8 GB of RAM. The operating system looks very much like Windows, gives you access to the internet, access to Wi-Fi, but it's designed to give you complete access to the I/O pins. So all these different pins over here are the I/O pins. You can read to them, you can write from them, you can write to them, read from them very easily with the Raspberry Pi Pico. So this kind of goes back to the old days of the PC. It's a PC designed for engineers. The current version of the Raspberry Pi is the Pi 5 that costs about $80 from Adafruit. And Adafruit is a really good website for engineers. We'll talk about that a little bit later. So that's the Raspberry Pi. The Raspberry Pi Pico came out in January 2021. This is a microcontroller version of the Raspberry Pi. Now, a microcontroller is similar to a microprocessor, except it's designed for I/O, and that's really what we want as engineers. We want to be able to read the I/O pins, write to the I/O pins, control the timing, things like that. So this is a Raspberry Pi designed specifically for I/O. Its features, it's got a dual ARM Cortex memory at 133 megahertz, about 20 times slower than a Raspberry Pi. 2 meg of flash memory, 264K of on-chip RAM. Again, the Raspberry Pi is about 8 gig, so a lot less memory, a little bit slower. Has 30 I/O pins that you can write to, read from. These are all 3.3 volt logic, capable of sourcing and syncing 12 milliamps. The nice thing about it, it's got 4 analog inputs, 12-bit A to Ds, sampling at 500 kilosamples per second. 2 serial ports, 2 I2C ports, 2 SPI ports, 16 PWM channels, one timer with 4 alarms, 1 real-time clock, 8 state machines. In other words, it's just a beauty to use for electrical engineers that want to do some I/O. And they're also cheap. The Raspberry Pi was $80. The Raspberry Pi Pico is $4 from Adafruit. That's the Raspberry Pi. What we're using is the Raspberry Pi Pico-W. That came out in June 22. It's the same as the Raspberry Pi Pico, but it adds Bluetooth and Wi-Fi. These are a little bit more expensive, $6 from Adafruit. Again, you go to Adafruit. This is Adafruit's website. Do a search for products like the Raspberry Pi Pico. Takes you to this page. Here's the Pico with soldered pins for $7. Buy it without the solder pins at $6. So one of the nice things about this class, we're using a very new processor. Only came out in June 2022. That also means there's not a whole lot of software written for it, which is part of the reason I think this course is going to be fairly popular in the general public. If you want to use the Pico-W, there's not a whole lot of code. Well, in this class, we're going to go over how to use the Pi Pico-W, how to use the various features on it, how to use the graphics display. Again, a lot of that code doesn't exist yet, but hopefully, from Bison Academy, you'll have access to sample code like that. Now, in terms of development boards, you don't really need a development board. If you go back and plug in the Pi Pico, all you need is connect it to the computer through the USB port. That provides power. It's running. It's basically a standalone computer. What the development boards do is they make it a little bit more convenient to write code and test it. The board we're using is a GeeekPi Breadboard Kit Plus. What that does is you need to buy a Raspberry Pi separate, plugs it in right here. But once you do that, it has access to all the I/O pins. And you've got a buzzer, 2 LEDs, an XY joystick, RGB LEDs, 2 push buttons, and this right here, a 320 by 640 graphics touchscreen. So you can write graphics to this display. You can use the touchscreen for input. That's stuff that we'll be doing. There's not a lot of documentation out on this board, a little bit in C, not much in Python. Well, in this class, we're going to go over how to access pretty much all the features on that board in Python. Now, there are other boards available. If you go to Amazon, there is a GeeekPi Breadboard Kit. This is kind of the same thing without the graphics display, but only costs $17. Plus, you get a bunch of jumper wires, a little breadboard. Yeah, pretty nice kit. Kind of one word of caution. If you plug this guy in, the buzzer goes off. What you need to do is take a resistor from the buzzer and solder it like a 100K resistor to ground. That has a floating buzzer. Ground it, the buzzer quits chirping at you. And you can see that on the back of my board. There's a 100K resistor I soldered from the buzzer to ground. Keeps it from chirping when you plug it in. Another breadboard that I really like is from Adafruit. If you go to Adafruit, so here's Adafruit, scroll down a bit somewhere. There it is. This guy right here is another breadboard. The nice thing about it is it has LEDs attached to all the I/O pins, so you can tell whether they're logic 1, logic 0. It's got a speaker rather than just a buzzer, so you can play Mary Had a Little Lamb, different tunes like that. 3 push buttons for inputs, a headphone output, a SD card, RGB LED. Kind of the same idea, without the graphics display though. So I think the graphics display is going to be really, really useful, so that's kind of why we're going with that one. So that's kind of the processor we're using and the breadboard, development board we'll be using. The language we'll be using is Thonny. If you go to thonny.com, so just type in Thonny, it'll take you here. This is a free programmer that we'll be using throughout the semester. I kind of like free. Actually, the Raspberry Pi Pico was designed to be run off a Raspberry Pi. A group in Estonia thought this is nuts, so they wrote their own Thonny driver for Windows and made it free and available to everyone. So we can all program the Raspberry Pi Picos and Thonny for free. In this class, we're going to be focusing on mid-level programming, or Python, specifically MicroPython using the Thonny programmer. Now, in terms of programming levels, the hardware on the microprocessor is what controls the inputs and outputs. So I can read my inputs, drive the outputs, all in hardware. Low-level programming is something we do in 376 embedded systems. With low-level programming, we have direct access to the hardwares. We can read and write registers, set up timers, set up the A to D converters, stuff like that. So that's kind of low-level programming. This is typically done in assembly in C. That's what we use in 376 embedded systems. In advanced embedded, we go down to here, mid-level programming. So rather than read and write the hardware directly, we're going to be calling subroutines that do all that, low-level driver routines. And we'll be focusing on more complex tasks, like driving the graphics display. High-level programming is typically something you do in computer science. That would be like AI. What kind of idea would be with quadcopters? If I just want to get the quadcopter motor to spin, that's low-level programming. Getting it to spin and make the quadcopter hover would be mid-level programming in a language like Python. Once you get it to hover, can I get the quadcopter to swarm? Or do a gradient search and find a gas leak? That'd be high-level programming, typically done in computer science classes. This is where we're focusing in 476, mid-level programming in Python. So that's kind of where we're heading. In terms of what embedded systems are, again, this class is advanced embedded systems. An embedded system is pretty much any electronic device that includes a microcontroller. It has inputs, where you read sensors, so the microcontroller knows what's happening in the world. It's got outputs, actuators to drive motors, lights, speakers, and a microcontroller that controls the outputs based upon the inputs. So this is kind of a fun course where you get to build, test, and demonstrate various devices. Fun because that's why you go into engineering. People go into engineering because you want to build stuff, and this is just a wonderful tool that lets you build things. Having a microcontroller really frees you up with what you can do, so this class is kind of unfair. Other classes like electronics, I want to control inputs and outputs without a microprocessor. You can do it, but you can do a whole lot more with a microprocessor. That's embedded systems. Also, this is a senior level course, and typically at the senior level, students don't know what they don't know. So that's kind of the point of this class. We've got 35 lectures, so we're going to be covering 35 different things you can do with a microcontroller. For advanced embedded systems, again, we talked about this a little bit, we're focusing on mid-level programming, focusing on more complicated programs rather than just reading and writing to the I/O pins. Do something with it. We'll be using drivers written by someone else, using a Python programming language, and we'll do things like control the speed of a motor using PWM. So that's what we're doing in this class. In terms of what you need to take this class, technically the prerequisite for this class is 376 embedded systems, but that's not entirely needed. What you do need to take this class is some programming experience. You need to know what is a program, what's a subroutine, how to write and debug code. You need a little bit of experience with circuits, understand voltage, current, resistance, voltage dividers, some basic op-amp circuits, and a little bit of experience with breadboards, how to build fairly simple circuits and then interface those to your Pi Pico. And again, mentioned that 376 is a prerequisite for this course. Not really necessary though. In 376 embedded systems, that's an NDSU course we teach, it focuses on low-level programming. So in 376, we focus on writing driver routines that access the hardware, set and controlling registers to set the frequency, duty cycle, stuff like that. The language we use is C and assembly because it's fast and gives us complete access to the hardware. using a PIC microcontroller. Now in 476, we are focusing on mid-level programming. We're going to call driver routines that somebody else wrote and focus more on complex tasks, like using the graphics display to display information. The language we're using is Python. That's an interpretive language which is very easy to use. I'm actually very impressed with Python. It is slower though. The process we're using is Raspberry Pi Pico. Again, came out just in 2022 for the W version. And we'll be doing I/O, such as serial I/O, graphics LCD displays, reading analog inputs, driving analog outputs. So really, you don't need embedded systems. We're using a different processor, a different language, with different objectives. So if you haven't had 376 embedded systems, that's probably not a big deal. Especially for people that aren't NDSU students. If you haven't taken that class, you're probably still okay. If you're a little bit rusty or something seems confusing, a good resource to go to is Bison Academy. If you go to Bison Academy, and this is Bison Academy, these are the courses that are offered. They're free, available online. If you go to electronics, these are the various topics, lectures, videos. There's homework sets. Go under homework sets and solutions. These are solutions with YouTube videos explaining them. If you need a refresher on some material, go to Bison Academy. It's free to use for anybody, not just NDSU students, with information on electronics, circuits, embedded systems, stuff like that. So you should be okay. Or should be okay if you haven't had embedded systems. In terms of course content, what we're going to be doing in Advanced Embedded Systems is for the first 4 weeks, we'll be looking at programming in Python, or technically MicroPython, a subset of Python for microcontrollers. We'll look at how to read and write in Python with binary inputs, analog inputs, and the use of libraries. Library is generally useful routines that have been pre-written, so you can reuse those routines. You don't have to start from scratch. We'll look at how to measure time in Python and output precise frequencies, as well as how to drive different types of motors. Motors with binary inputs and analog inputs, both DC and AC motors. Then we'll have the first test. The following 5 weeks, we'll introduce the graphics display. How to read and write to the graphics display, a library created just for that graphics display, and some things you can do with it, like play a lunar lander game. Look at the math and random libraries. Interrupts. Interrupts are subroutines called by hardware. With embedded systems, we looked at interrupts on a PIC microcontroller. With the Raspberry Pi Pico, you can also have interrupts. I can have interrupts triggered on edges, like rising edges, falling edges, when I hit a button. I can have timer interrupts. With those, I can control the speed of a DC motor, control the angle of a DC motor, like open and close a valve. I can read various types of sensors. We'll look at analog sensors, reading those, reading digital sensors. Once I've got some sensors, I can collect data. How to collect data, store it to a text file, and then analyze that data using recursive least squares, and do things like find the time constant for a coffee cup, determine whether NDSU cups are better than UND cups, and of course we know the answer is yes, but we can show that. The following 4 weeks, we'll look at the touchscreen. So with the screen here, you cannot just write to the graphics display. I can use this as a touchscreen and use that as a form of user input. We'll look at state machines. Those are ways of calling different programs at different times. Doing I/O through Bluetooth, so you can talk to your cell phone using a Raspberry Pi Pico, and Wi-Fi. Read and write to the internet with a Raspberry Pi Pico. So that's kind of where we're heading. The bulletin description of this course is specification, design, development of modern embedded systems using a high-level programming language, basically using a Raspberry Pi Pico and Python. The course objectives are by the end of this course, you should be able to interface a microcontroller to binary inputs and outputs, interface it to analog inputs and outputs, use a graphics display and a touchscreen for I/O, be able to send and receive data to your cell phone using Bluetooth, send and receive data to the internet using the Wi-Fi connection, and do all of that using Python. The resource, the textbook for this course, is Bison Academy. So again, if you go to Bison Academy, scroll down to Advanced Embedded. These are all the lectures. The videos don't exist yet. I'm recording those right now, but shortly we'll have videos for all the lectures. Sample code. This is code that shows up in the lectures. Rather than type it in by hand, you can just click on this, download that to your Pi Pico, and check out to see how the program works. Various homework sets, and once the homework's turned in, I'll have the solutions posted. They're not there yet. Eventually, there will be homework sets and solutions under Bison Academy. Currently, this course doesn't exist, so fall 2024 will be the first time the course runs. So after that, there will be homework sets and solutions. None yet, but eventually there will be. One thing that I would ask, if you take the course, typically the homework sets will have 4 parts. The requirements tell me what you're going to do. The hardware and software design, test your design to make sure you met the requirements and it works. Then validation and demonstration. A good way to test and validate your code is to make a YouTube video. So make a YouTube video, share it with me, and that'll be your testing validation. The nice thing about YouTube videos is the hardware probably won't work a week later because you'll rip it apart for the next assignment. YouTube videos will be there forever. So if you want to show off what you've done in this course to employers, make a YouTube video. The better videos, with your permission, I'll post under 476, under Best of 476, and you can see what other students have done. Again, currently there isn't anything under Best of 476 because the course hasn't run yet, but eventually there will be a Best of 476 section. The lab kit, as mentioned before, is the GeeekPi kit from Amazon. Also available from eBay. Again, the kit makes the course a whole lot more fun. The whole reason you go into engineering is you want to build things. The development board or breadboard kit makes it a lot easier to write code and test your code and see that it works. So it makes the course a whole lot more fun for not a lot of money. It's $32. Think of it like a textbook that you're actually going to use. Plus, I'm willing to bet that you're going to reuse this when you take senior design. It's a pretty nice board. In terms of how you can take the class, this class is offered in the full Hyplex version. What that means is the class is offered in person, live streamed on Zoom, and online through YouTube videos. You can take the course however you want. If you decide one day you want to show up in person, next day you want to take it in, just live stream it, next day watch the YouTube video, I don't care. However you get the material is up to you. If you signed up for the online version and want to show up in person, you're more than welcome. Typically what happens in my classes is the first week everyone shows up in person, and by week 2 or 3 people realize that everything's available online, so they just watch the videos. So by the 3rd week I'll have 2 or 3 people show up in person. If you want to show up in person, you're more than welcome. I'll have a class of like 2 or 3 people. Kind of fun that way. If you want to take it online, you're more than welcome. Again, everyone's welcome to use whatever resources you want. In terms of grading, grading is 3 midterms, homework, term project, final exam, all with equal weightings. And the final grade is rounded at the nearest 1%, 90 or higher is an A, 80 or higher is a B, 70 or higher is a C. I'll round down, but I won't round up, meaning 90% guaranteed to have an A. 89, maybe, maybe not, depends on the curve. I do that because if everyone works together, everyone learns the material, everyone demonstrates, everybody gets a 90%, I'm happy to give out all A's. I'll have to justify that to my chairman, but if I can say, here's the objectives, here's how people demonstrated, they met each objective, I can do that. Sometimes the tests get a little bit overly ambitious for my part, so if the tests were harder than I really anticipated, I'll curve down, but I won't curve up. So if you got a 90, you got an A. That being said, if you want to get an A or B in the class, what I highly recommend is keep up and do the homework. Programming is a lot like weightlifting. If you watch somebody else lift weights, it really doesn't do you any good. You got to lift the weight yourself. In programming, you got to write the programs yourself. You got to go through the debug process, find out why it works, why it doesn't work, how to make it work. That's about the only way to figure out programming. So there are homework assignments and tests. The homework assignments, you can probably get by with that, having your lab partner do the homework. The reason there's tests is that's what I'm checking on. If you did the homework, the tests ought to be pretty easy. If you gave moral support on the homework, then you're going to really struggle. So really, do the homework. And oftentimes, grading this class is bimodal. The people that did the homework get A's and B's. The people that didn't do the homework really struggle. The midterm is not where you want to learn the material. And also, for the homeworks, typically the homework will be design something using pulse width modulation. It's your pick how you do that. On the homework, you can work in groups of 1 or 2. The reason I don't like 3 is once you get to 3 people, usually one person gives moral support. With 1 or 2, usually both people are contributing. So you can work in groups of 2. If you do that, just turn in one homework set and mention who the other person is, and I'll give both people the same grade. Exams, however, are to make sure that you're actually doing the homework. Exams are not in groups of 1 or 2, they're individual. Again, the purpose of the exam is if you did the homework, it's easy. If you're giving moral support or copying or find some other way, like using ChatGPT, you'll struggle on the tests. And the homework tends to be open-ended. That lets you tailor the course for your own interests. Again, I'll ask you to do something using pulse width modulation. What you do with it is totally up to you. So typically on the homework, you'll have requirements, paper design, test and validate, demonstration. This is typically what you do in industry. In industry, you're not paid to grind out numbers on paper. In industry, you're paid to solve problems. And typically what you need to do is specify the requirements. What does the device do? What are the inputs? What are the outputs? What's the functionality? Design something to meet those requirements, test your design, and then demonstrate it, deliver it to a customer. We'll be doing that on every homework set. And so for the write-up, I kind of need to know what you did, since everyone's going to be different. Tell me what your device is supposed to do, how you designed it, both in hardware and software, how you tested it, validated it, and then demonstrated. That's your YouTube video. And finally, legal stuff. Attendance is required in this class. However, how you attend is up to you. You can attend in person, you can live stream the class, you can watch the YouTube videos. I don't really care. Long as you can do the homework and pass the tests. If you have special needs, let me know and we'll accommodate you somehow. In terms of academic honesty, the point behind the honesty statement is when you graduate, you're going to be designing things like defibrillators, pacemakers, flight controllers, stuff that affects people's lives. If you find a way to get through NDSU without learning the material and getting an A, please don't. Again, you're going to need this stuff when you get to industry. It's better to learn it here at NDSU than when you get to a company and you find out that you don't actually know anything. So, again, courses aren't perfect. If you can find a way to get an A without learning anything, that's not the point. The stuff in this class is actually really useful and it's fun. So if you find a way to get an A without learning anything, still learn something. Again, because that's the whole reason you go into engineering, you want to build stuff. This is a class where you get to build stuff. And if you're a veteran, again, let us know and we'll accommodate you somehow. So that's kind of an introduction to ECE 476. It's a course that I hope is a whole lot of fun. Hope you really enjoy it. I really enjoy playing with this PIC microcontroller, or the Pico microcontroller. Hope you're going to enjoy it too. So with that, I'll let you go, and the next video we'll start talking about Thonny and MicroPython.